Hello students, I'm back here again with yet another video on our channel Euclid Mathematics. We already started lecture series based on the M3 subject. So this one is our second lecture. It's going to be really interesting. I hope you all have understood my previous lecture. So if you didn't see that video, go and check that video again and then come to my today's lecture. So in our today's video, I'm going to continue my previous lecture here in my today's video. So let's get started our today's solution with a linear differential equation with a constant coefficient. Already I explained here in our channel how to solve nth order differential equation. Okay, so actually which contain two methods, which is one of the complementary function and another one is the particular integral. So in our today's lecture, I will explain to you all how to solve complementary function, using the roots of our solution. Okay, so for finding the complementary function, we have to deal first of all the roots of our quadratic, cubic or nth order differential equation. Okay, so let's get started our today's solution with the complementary function. So here in our today's lecture, we will check how the auxiliary equation behave like. Okay, in our previous lecture, we up to the point like f of d as a auxiliary equation into y which is equal to 0. Okay, so till that step we learn in our previous lecture. So onward now we are going to decide complementary function and particular integral. Okay, so for about the complementary function, we first of all go for finding the roots of f of d. Okay, so maybe it is a cubic, quadratic. Now see that means if you have quadratic equation, obviously you will get the two roots. If you have cubic equation, you will get the three roots. If you have fourth power equation, that means you will get the four root. That means the highest power represent number of roots in our equation. Okay, so for example, if I have quadratic equation, okay, if I have here quadratic equation, okay, obviously quadratic equation means like which is in the form of ax square plus bx plus c which is equal to 0. Okay, this one is the quadratic equation. Now consider that I got the first root as the m1 and the second root as the m2. Okay, so I got the two roots from our quadratic equation. Okay, so now see that here we can observe that m1 m2 are the two roots from our quadratic equation. But there is also condition. These root may be real, maybe they are distinct, or maybe they are complex. We have only three options for our roots. Okay, which first option we have here, the roots are real and distinct. First option it is here, the roots are real and distinct. Second option, now first option we know that if the roots are real and distinct, but that real roots means which contain all numbers other than complex. Okay, second one, real and equal, that means all roots are similar. Like if I do have m1 and m2 are the two roots. Okay, real and distinct, that means both are real but not equal. Okay, real and equal, that means m1 which is equal to m2, all roots are equal. Okay, but they are real. And third option we left here with the complex root. Okay, that means the value for m1 comma m2 which belongs to the complex number. Okay, which belongs to where it belongs to the complex number. Okay, so these are the main generally three types of our roots. Okay, so using these three roots we are going to define solution for our differential equation. Okay, so I'm first of all I consider here only the quadratic equation. If it is cubic, if it is nth power, okay, and then I will explain to you all how can we write their solution. Okay, now see that here very carefully you all need to observe here how I'm going to write the solution. Okay, using our roots. Now see that if I have real and distinct root, okay, like m1, m2 both are not equal, okay, and they're distinct, okay, but from a real number. Okay, then we write the complementary function as y of x or complementary function. Okay, so we write the y of x as a c1 e to the power m1x plus c2 e to the power m2x. Okay, c1 e to the power m1x plus c2 e to the power m2x is the solution. When we have only two roots, what happen if that root's going to be higher and higher, like a m3 it is there, again m4 are there, okay, then so on, okay. That means our nth power equation which is present there, okay. So this many type of the solution we have here, okay. Then how can we write the solution for our given roots, okay. So see that c1 e to the power m1x, now how many times roots are repeated, write down these many constant, okay. c3 e to the power m3x plus c4 e to the power m4x and plus so on, okay. So this is the actual complementary function or general solution for our differential equation, okay. Now see that, don't get confused, I will explain with some of the example, okay. Now see that example I consider here, one of the example, okay, that how can we write the solution. Consider that 3 minus 4 5, okay. These three are the roots, okay. These three are the real and distinct root from our auxiliary equation, okay. These three are real and distinct from auxiliary equation, and we know that all are belongs to the real number, okay. And we write its solution as y of x, which is equal to c1 e to the power m1 means consider first root as m1, okay. This one m1, again second as m2 and third as a m3, okay. So we have three roots here, c1 e to the power 3x plus c2 e to the power minus 4x plus c3 e to the power 5x, okay. This one is the complementary function or complementary solution for our differential equation. Now see that guys, how easy the solution it is. We are getting such a question for 3 or 4 marks in our university exam. So it's not that difficult to get the good score in our M3 subject, but you all need to be good with the basic concept, okay. So now see that I explain here when roots are real and distinct, okay. That means m1, m2, m3 and so many roots are there, okay. Then we write their solution in this form, okay. So what happen if roots real and equal? What happen if roots are real and equal, okay. Now see that I'm going to consider here second part. Roots are real and equal. What happen if roots are real and equal? That means m1 which is equal to m2 which is equal to m3 which is equal to, all are equal, okay. I consider here only three roots. So as you're going to consider root, your solution it will change, okay. So consider that I do have three roots here. Then we write complementary function as c1 plus c2x plus c3x square e to the power mx and m1, m2, m3, all these are equal, so I consider their name as m only, okay. So complementary function I write c1 plus c2x plus c3x square which is equal into e to the power mx as the solution. When we have three roots, what happen? It is only it only has the two root m1 which is equal to m2, say that one. Then we write complementary function c1 plus c2x e to the power mx, okay. The many root we have here, the many constant we are getting here, okay. Yes. Now see that these are the roots for our differential equation, and don't get confused, okay. This one, and I'm going to write another one here, c1 x square plus c2x plus c3 e to the power mx, okay. These both solutions are same, don't get confused. They are constant are looking different, but constant doesn't matter in differential equation, okay. So both are the similar roots here, okay. So similarly you can write here c1x plus c2 e to the power mx, okay. This is a complementary function, so both are the right answer, okay. Both are the right answer, okay. I hope you all have understood when roots are equal and real and equal, then how can we write the solution, okay. And last part which remain here, when roots are complex, okay. Let's go for the third one. When roots are complex, what happen if roots are complex, okay. Now let's consider that first of all let me explain what is meant by the complex root, okay. Then roots which is in the form of a complex number, like we know that complex number can be written as a plus minus ib, okay. A plus minus ib, which is the complex number, okay. So if roots are in this form, a plus minus iota times b, then how we are going to write the solution? Now see that carefully here. The solution for our differential equation, okay, consider that these are only two roots, okay, these are only two roots. Then we write e to the power ax c1 cos bx plus c2 sin bx, okay, e to the power x c1 cos bx plus c2 sin bx, okay. This one is our solution for our differential equation whenever we have only the two roots, okay. And what are the value for a and b? A which is coming from here and b which is coming from here, okay. Now let me explain with a short example, okay. So if I got the root here, okay, let me consider one of the root here, okay. 3 plus minus 4i, okay, 3 plus minus 4 times I, okay. I consider here 3 plus minus 4i is one of the root for our auxiliary equation. Then we write its solution y of x, which is equal to e to the power ax. Now see that, compare these two complex number with each other. Now see that what is the value for a. I am going to write a as a 3 because a as a 3 and b as a 4, okay, and b as a 4. Now see that how easy the value coming, okay. So a plus minus b means 3 plus minus 4. So a which is a 3 and b which is a 4, okay. Now replace the values here in our solution. We are going to write this one as e to the power 3x under bracket c1 cos 4x plus c2 sin 4x, okay. This one is our solution. Now see that how easy the solution it is coming, okay. Now what happen if we get the two times complex root, okay. That means if we get the complex root in the form of x plus minus iy and a plus minus ib, okay. That means these are complex and different roots, okay. Then we write its solution as, okay, we write its solution as y of x, which is equal to c1 e to the power ax, okay. E to the power ax, it will remain same, e to the power ax c1 plus c2x, okay. We write c1 plus c2x, we write c1 plus c2x cos bx plus c3 plus c4x sin bx, okay. This one is the entire solution, okay. That means a and b, the value you have to take it in the form of repeated value here, okay. So a it is coming here, b it is coming here. So these are the repeated complex roots, okay. Whenever we have repeated complex root, we are going to use this solution, okay. So I hope you all have understood how can we write actually the solution for our different types of the root, okay. So we are going to continue some of the example, then it is easier to understand. But before I start example based on the complementary function, I feel that we have to go for one of the review on a synthetic division, because most of the students, they are not familiar with the synthetic division. And so I feel that I have to go for one more extra lecture, separate lecture for finding the roots using synthetic division. Okay, so that's it for our today's lecture. In our today's lecture, we learn how can we write the solution for our differential equation whenever it has the three type of the roots, okay. So I will share with you all the notes that I have taught in our today's lecture. See guys, here these are the three part here. When roots are real and distinct, we write its solution, this one, or real and equal, then we write the solution here, and roots are complex, okay, then we write the solution here, okay. Now see that, take the note of these 3 points. These are important here for our today's lecture, okay. So that's it for our today's lecture. I hope you all have understood. In my next lecture, we are going to understand synthetic division and how can we find the roots using synthetic division. It's one of the easy method for finding the roots of using synthetic division. So that's it for my today's lecture. So thank you everyone. Thank you for my today's lecture.